Hello and welcome to Calculus tutorial. We've got two examples to take a look at here for two new derivative rules, the product rule and the quotient rule. Two very important rules that we're going to keep using over and over in this class. So first, the product rule. So you need to use the product rule anytime you have two functions that are multiplying by each other. Anytime two expressions with an x are multiplying to each other. So to give you a very basic rule for this, the product rule is going to be you take the first function and you take its derivative and then you multiply by the second. Whatever it is, you don't take the derivative, plus, then you take the derivative of the second and multiply by the original first without the derivative. Okay? Another way to put that, a little bit more mathematically sound, if you have the derivative of f times g. So a function times a function. You do f prime times g plus g prime times f. The derivative of the first times the second plus the derivative second times the first. So let's take the derivative of these two functions that are composites of two functions, f prime. So we're going to take the derivative of the first. The derivative of 2x minus 3 is just 2. Times the second, x minus 4. I'm not going to change the x minus 4 at all. Plus the derivative of the second, x minus 4, the derivative of that is just 1. Times the first, 2x minus 3. And so if we work on simplifying that a little bit, you get 2x minus 8 plus 2x minus 3. So that looks like that will give us 4x minus 11 is our final derivative. It's kind of a long and complicated process, but with this one I can prove that it works because I can do this problem another way. If we distribute first, all right, not doing calculus here, just going to write this problem in a different way. So this is regular f, no derivative, no calculus yet. 2x times x is 2x. 2x times negative 4 is negative 8x. Oops, I forgot the squared. And then negative 3 times x is negative 3x. And negative 3 times negative 4 is positive 12. And you get 2x squared minus 11x plus 12 is f. And hopefully you can take that derivative in your head. 2 multiplies the 2 gives you 4x, and the derivative of negative 11x is negative 11. So it thankfully checks out. You won't always be able to do that. There are not always two ways to take a derivative. Like example number 2, we only have one option to take this derivative, and that is the product rule. So the derivative of the first, 16x, times the second, plus the derivative of the second. The derivative of cosine is negative sine, times the first. So let's see, we took our derivative and now we can probably simplify this a little bit. I see an 8 in common with these two terms and an x, so I'm going to factor out an 8x. And what will be left 2 cosine x, the positive and negative, minus, and I'm going to put the x's in front, we'll have an x sine x left over. Don't forget my second set of parentheses there. So that is our derivative using the product rule. All right, so let's take a look at the quotient rule next. Let me get rid of all this. It is our second most important, more complex rule. Surprisingly enough, it's what most people do better later in the course, but it's definitely harder than the product rule. But it does have some similarities. So first off, if you're going to do the quotient rule, here's what you take a look at. You have two functions that are dividing each other. So one on top, one on bottom. And I, again, to use the same vocabulary, I call this one the first and this one the second. And that way it looks a lot like the product rule. You take the derivative of the first times the second, but this time you subtract the derivative of the second. So there's the first slight change, times the first. And because we are doing the quotient rule, it is still a fraction. You take that bottom one, the second, and you have to square it. So, a slightly more mathematically sound version, if you have f on top and g on the bottom, you take the derivative of the first times the second minus the derivative of the second times the first, all over that second one squared. All right, so let's do this one. So the derivative of the first, y prime. The derivative of the first will be 2x minus 1 times the second minus the derivative of the second. The derivative of x plus 4 is just 1 times the first all over the bottom one squared. And then it becomes a game of how much do you want to simplify and how nice do you want this to look. You should at least multiply out and add and subtract the top. So I will do that. So you get 2x squared plus 8x minus x minus 4. We will combine the like terms over here. So we'll have 3x squared. 8 minus 1 is 7. Oh, actually, careful. I think I messed that up because oftentimes what you get is a negative that must distribute. So that is actually a negative, that is actually a positive, and that is actually a positive. So we have 2x squared minus an x squared just gives us 1x squared. So again, 8 minus 1 is 7, plus 1, however, gives me back to 8. And then a negative 4 and a positive 20 makes 16. Divided by x plus 4 squared. Gets much nicer. Now, can we do that again? Actually, yes, we can, because the top factors, doesn't it? Into x plus 4 times x plus 4. Look at that. Over x plus 4 squared, which, hey, look, doesn't that all cancel out? X plus 4 cancels out 2 of those on the bottom. And it's not 0, that is 1. All cancels out to be 1. Kind of angering, actually, especially since this one we can check our answer because this one we can factor from the beginning. So here's a second way of doing this problem. So this is regular old y. X squared minus x minus 20 does factor to be x plus 4 times x plus 5. Sorry, which one is negative? The 4 is negative. There we go. Divided by x plus 4. Oh, no, I did get it wrong again, didn't it? The 5 is negative. It's like I knew this worked out. Plus 4 minus 5. And so the x plus 4's cancel out. Y is equal to x minus 5. And what is the derivative of x minus 5? 1. So our answer checks out. All right, now that one is just a proof of concept to show you that the quotient rule does work. Oftentimes you cannot check your answer that way. You cannot do the problem two ways. Like example 2, where your only option is the quotient rule. So we should be able to rattle this one off pretty quickly. The derivative of the first times the second minus the derivative of the second times the first all over the bottom one squared. Now, is there anything we can do to simplify this? Distribute the 4, that becomes negative 8x squared. So over here, trying to save some space, we get 4x squared plus 24. Combine those on the top. 4x squared and negative 8x squared is negative 4x squared. Still have the plus 24 divided by x squared plus 6 squared. Yeah. Will any of that simplify? It doesn't look like it. Gets really close, doesn't it? If we factor out a negative 4, we get x squared minus 6. Shoot. That's really close. But those two do not simplify, sadly. Oh well. We don't really have any other way of checking our answer. So there is our derivative. So hopefully that helps with the product and the quotient rule.